This video is to show you how to use the TI-84 calculator to solve systems of equations using inverse matrices. The first thing that we need to discuss is what an identity matrix is. An identity matrix is a square matrix. That is a matrix where the number of rows equals the number of columns. In an identity matrix, there are ones down the main diagonal from left to right and zeros everywhere else. This is an example of an n by n identity matrix. An identity matrix has the property that when another matrix is multiplied by an identity matrix of the appropriate size, the result is the original matrix. If there exists a second matrix, then when it is multiplied by the original matrix from both sides and the result is the identity matrix, then the second matrix is the multiplicative inverse of the first matrix. It then satisfies both conditions shown here. It is called the inverse of A and is written as A to the negative 1 power. This means that only a square matrix might have a multiplicative inverse. Even so, there are some square matrices that don't have an inverse matrix, and we will discuss some of the implications that arise from this later. This slide shows the step-by-step method on the TI-84 calculator for finding the inverse of a square matrix, if one exists. Please note step 5. If there is not an inverse matrix for your matrix, error singular matrix is the error message that you will receive. I would recommend that you make a copy of this page, at least until you have the steps memorized. On this next slide, I will show you how to find the inverse of three matrices using the TI-84 calculator. To do this first example in the TI-84 calculator, press second, matrix, press the right arrow twice to go to edit, select number 1, A matrix, type in 2 and press enter, type in 2 and press enter. This sets the dimensions of your matrix to 2 rows and 2 columns. Type in negative 1 and press enter. Type in 5 and press enter. Type in negative 3 and press enter. Type in negative 1 and press enter. These last 4 steps have input the elements of our matrix. Press second quit. Press second matrix. Select number 1, the A matrix, the one we just created. Press the inverse key. Press enter. This gives us the inverse matrix with decimals. Press math. Select number 1, fraction, to convert the decimals in the matrix into fractions. Press enter. This is our answer matrix. Press second, matrix, select number 1, the A matrix, press the inverse key, press the times key, press second matrix, select number 1, the A matrix, press enter. We get an identity matrix. Press second matrix, select number 1, the A matrix, press the times key, press second matrix, select number 1, the A matrix, press the inverse key, press enter. Again, we get an identity matrix. These two matrices are inverses of each other. To put it simply, when these two matrices are multiplied together, they will nullify or cancel each other out. To do the second example on the TI-84 calculator, press second matrix, press the right arrow twice to go to edit, select number 1, the A matrix, Press enter twice. The dimensions of 2 rows and 2 columns are already in the TI-84 calculator. We do not need to put them in again. Type in 3 and press enter. There is no need to clear the last entry. It's automatically cleared. Type in 6 and press enter. Type in -1 and press enter. Type in -2 and press enter. Press second quit. Press second matrix. Select number 1, the A matrix, the one we just created. Press the inverse key. Press enter. This gives us an error message for a singular matrix. Error singular matrix. This is a singular matrix. It does not have an inverse. Press second quit. If you take each element of the top row and divide it by -3, you will get the corresponding element in the bottom row. These 2 rows are multiples of each other. This is what produces a singular matrix. Since these 2 rows are multiples of each other, there is no matrix we can use to perform a matrix multiplication that will produce an identity matrix. This matrix does not have an inverse. To do the third example on the TI-84 calculator, press second matrix. Press the right arrow twice to go to edit. Select number 1, A matrix. Type in 3 and press enter. Type in 3 and press enter. This sets the dimensions of our matrix to 3 rows and 3 columns. Type in -2 and press enter. Type in 1 and press enter. Type in 1 and press enter. Type in 0 and press enter. Type in -1 and press enter. Type in 0 and press enter. Type in 3 and press enter. Type in -1 and press enter. Type in -1 and press enter. These 9 steps have input the elements of our matrices. Press second quit. Press enter. Since the last command is A inverse, we don't need to put it in again. By pressing enter, we get the solution for the new matrix A that we just input. This is our answer matrix. On the TI-84 calculator, press the up arrow 8 times. To find the line that proves inverses, press enter twice. We get an identity matrix. Press the up arrow 8 times. To find the line that proves inverses, press enter twice. We again get an identity matrix. These 2 matrices are inverses of each other. This slide shows us how to solve a system of equations using the inverse matrix method. First, we must make sure that the systems of equations are in the proper order. Where the variable terms are in alphabetical order on the left-hand side of the equation, and the constant terms are on the right-hand side of the equation. Next, we need to make 3 matrices from these 2 equations. These matrices are formed from the coefficients of the variable terms, the variables themselves, and the constant terms. They are called the A, X, and B matrices, respectively. The left-hand side of the equations is the product of the matrix multiplication of the A and X matrices. Now, multiply both sides of the inverses by the inverse of the A matrix. On the left-hand side, the product of the inverse A matrix and the A matrix is the identity matrix. The identity matrix multiplied by the X matrix is still the X matrix. The X matrix represents our variables of X and Y. The matrices on the right-hand side, which is the inverse of the A matrix times the B matrix, is our answer matrix. The green indicates the two matrices that you need to create. The blue shows what you need to input into the main screen of the TI-84 calculator to get your answer. This part shows the steps of the matrix method in general terms, which can be applied to any size square matrix. Now, since this method requires an inverse, this means that this method can only be used for systems of equations where the number of matrices and the number of equations are equal, because only square matrices have inverses. This is one of the limitations of this method. To solve the systems of equations on the TI-84 calculator using the inverse method, press second matrix. Press the right arrow twice to go to edit. Select number 1, A matrix. Type in 2 and press enter. Type in 2 and press enter. This sets the dimensions of your A matrix to 2 rows and 2 columns. Type in -1 and press enter. Type in 3 and press enter. Type in 4 and press enter. Type in -11 and press enter. These last 4 steps have input the elements of our A matrix. Press second quit. Press second matrix. Press the right arrow twice to go to edit. Select number 2, the B matrix. Make sure you select a different matrix than the first one you created. Type in 2 and press enter. Type in 1 and press enter. This sets the dimensions of your B matrix to 2 rows and 1 column. Type in 8 and press enter. Type in -28 and press enter. These last 2 steps have input the elements of our B matrix. Press second quit. Press second matrix. Select number 1, the A matrix, the one we just created. Press the inverse key. Press enter. This gives us the inverse of the A matrix. Now you have a choice to make. You can either load this matrix into a third matrix, say C, and complete the matrix multiplication with the C and B matrices, or you can let the calculator do all the work, which is what I would recommend. Press second matrix. Select number 1, the A matrix. Press the inverse key and the times key. Press second matrix. Select number 2, the B matrix. Press enter. This gives our answer of 4, 4. On this slide there are 2 examples, one for infinitely many solution system and the other for a system with no solutions. These 2 systems are similar. Notice the left-hand side of both equations are the same. On the infinitely many solution system, the second row is a multiple of the first row. What I mean is, if you multiply each element of the first row by 2, you get the second row. On the no solution system, the variable terms only on the second row are multiples of the first row. What I mean is that if you multiply each element of the first row by 2, you will get the variable terms, but not the constant term. This is the basic difference between the systems of infinitely many solutions and no solutions. To do these two examples on the TI-84 calculator, press second, matrix, press the right arrow twice to go to edit, select number 1, the A matrix, press enter twice. The dimensions of 2 rows and 2 columns are already in the TI-84 calculator. Type in 1 and press enter. Type in 2 and press enter. Type in 2 and press enter. Type in 4 and press enter. Press second quit. Press second matrix. Select number 1, the A matrix, the one we just created. Press the inverse key. Press enter. This gives us an error message for a singular matrix. Error singular matrix. This means that there is no inverse for the A or the coefficient matrix. This means that we cannot use this method to solve systems of equations with infinitely many solutions or no solutions. It tells us that we have one of the two systems, but not even which one. The inverse method fails for all systems of equations that are infinitely many solutions or no solution systems. We must then decide which of the other methods we can use. This means that the inverse method has 3 strikes against it. The first strike is that the inverse method requires square matrices. This means that the number of equations and variables must be equal in the system. The Gauss-Jordan method works for all sizes of systems, and therefore it is not limited to square matrices. The second strike is that the inverse method does not have the capability of giving an identifiable answer for systems of equations with infinitely many solutions or no solution systems. It simply does not work for them. The only method that does work is the Gauss-Jordan method. So why not use it from the beginning? The third strike is that the inverse method requires more steps for performance than does the Gauss-Jordan method, even on the TI-84 calculator. This is especially true in a computer system, where it requires more than twice as many steps to solve a system of equations, if it can be solved. So why not just use the Gauss-Jordan or RE method from the beginning? The Gauss-Jordan or RE method is the preferred method to use for solving systems of equations. This does not mean that the inverses have no value. They do. They are used in cryptography, which will be the subject of a future video. Just make sure that your encryption matrix has an inverse before you encrypt your message, or you will never be able to decode or unencrypt your secret message. That's it. We're done. Thank you. Bye.